for Robotic seminar, and thank you for joining in person such a day in the middle of the summer and also remotely. I'm very honored to introduce today Dr. Sami Atiya. I have known Sami for more than 30 years. We were in a basement together doing robotics research together with Greg Hager, a GRASP. This is how I got to know also the GRASP Lab. And Sami did really some brilliant work on robot localization, avoiding using Gaussian assumptions for error and using really intervals. And I was just checking your PhD this morning, and it was really beautiful, like formulation of the localization problem. And since then, Sami finished his PhD a little later. He did an MBA at MIT, and he followed a leadership career, but most of the time very close to robotics or even also medical applications. So I'm gonna list all the positions he had had. He was the CEO of computer tomography at Siemens. One of the, if you have been in the hospital, most of the machines are from Siemens. So he was the CEO of mobility and logistics at Siemens as well. And since 2016, he is the president of the Robotics and Discrete Automation of ABB. ABB is the leading provider of industrial robots with a market share of more than 20%, a $3.6 billion, and employs 11,000 people around the world. And it is very rare to have somebody from such in the leading an industry with such impact in the GRASP Lab. And we are really very fortunate to have Sami today, who will talk about the evolution of robotics and industry perspective and AI. All right.
Super. Thank you very much, Kostas. Thank you all for joining. It's a pleasure to be here. It's a real honor to be in the GRASP Lab and talking to you today. I thought, since we have so many smart people in the room, what could be my contribution for you? So I'm not going to talk about, robotics research. I'm going to talk about robotics from the perspective of the industry and how we see, the evolution of robotics over the years, what drove what decision that we made, and why we believe that robotics will continue to be on a growth path, and what are problems actually in the industry and society robotics is solving. And then at the end, I will switch topics about 10 minutes and talk about how AI is used in industrial application. It's more of a general overview of how we think of AI, since it's all over us. I wanted to share some thoughts around that as well. But let me start with the robots that I was working on in my PhD. I was sitting, as Kostas mentioned, in the basement near his room, and we would go home around 3 or 4 o'clock in the morning, now for many, many years. And I mean, look at it. It's a 2-arm robot, a platform a mobile robot, vision system, and what have you. And what I wanted to share is, a recent acquisition we did and research we're doing. It's a mobile robot that has, VSLAM that is working. My point is it is 30 years until proof of concept, until it really reaches industrial application. There are reasons for that, and I think it would be probably also interesting. Morning. Hello. Hi. No problem. Hey, hi, Rosanna. We just started. Great to see you. I was just starting to talk about the robot that I was working on with Kostas. We were in the basement together, and how long it took from a robot concept for reality. We have that now, and I'll show you a video how it actually is working today. And there are lots of things that you could need to consider between the proof of concept until it works. So company, we are a large technology company. As ABB, we do process automation. That means we monitor plants, power plants, for example. We do electrification of everything that is in here. We have the business of motion, and I lead the robotics and discrete automation, which, as Kostas has mentioned, is about 11,000 employees. We're in 50 countries, and we basically sell robots, but also we sell the solutions around it. And that's something where I would like to dwell a little bit deeper on. How are robots actually embedded in the industrial world? What does it mean for a company? And what is our role between what we get from the university as science, how we deliver that and make that real for our customers? This is the first robot that was produced by ABB. It is from Atiya, 1974. It's the first microprocessor-controlled robot. As you know, before that, you had to basically use either tapes or fixed programs. So you put it in and the robot runs. And this was the first programmable one. It worked for more than 40 years until actually the company did not exist. So they had to shut it down. But it was quite robust. 40 years is a quite long time. And this is how robots really look today. These are applications in automotive where you coordinate multiple robots doing fantastic production enhancements for our customers. So a long way from the initial robotics to what we see today. Now, what happened over the years? So these are the number of robots that I will show you later why actually they went up over time. But first, from a robot perspective, 1974, first robot. And then we had many advancements of the same type of either 4 or 6 axis robots. And then over time, we saw that there is a need for much more specialized robots. And that's how things were created, the need for not only 6-arm, but others. And you can see first electric drive paint robot. And I'll tell you why it is a little bit different using a paint robot than a classic robot. Delta robots are the pickers. And then we had the smaller robots, the scale robots for electronics. First dual arm robot, and then hygienic robot for food and beverage. And then the GOFA, which is a collaborative robot. Collaborative robots you might probably know about. It's how you interact with the robot. You put it in a place and it interacts with the human. It's also a very specialized robot. And then we had the autonomous mobile robots get into the industrial world where you mount a robot on a platform. Now, this is the evolution of the mechatronics. But what helped was the evolution of the software as well. So first was the whole development of the underlying microprocessors. And that was key to enable robots actually to be programmed. Now, today it sounds like normal, but having a platform to program on is something very unique until the 1990s. And then there was a whole movement of new software that enabled us to do more new applications. I mean, Pickmaster is basically a software that allows a fast picking of food, or the Robot Studio, which is something I will dwell on deeper. Robot Studio is a simulation tool that was fundamental for the development of robotics. We use it basically to do everything virtually before we even do implementation. Even the PLC code that we develop on the Robot Studio is actually the same runtime. This is absolutely critical because when you go to a customer and you tell the customer, well, this line I will fully automate. The customer will say, well, what does that mean? I have a running system, don't touch it. So we show it beforehand, we simulate, we exercise all the safety aspects and so on. And when the customer feels comfortable, we actually use it. So that was critical for the development. And then we had virtual commissioning, easier programming, which started in the last 5 years. Easy programming is quite important for the development of robot because the complexity of programming a robot is quite immense. And then we put the Robot Studio on cloud, so multiple sites can work together. And then we had the actual development on top of these software, new sensors coming in. So this is when vision started becoming relevant, visual surveying, and other applications that were built on top of the existing software. So when we were working on vision like 30 years ago, we didn't really have the platform in the industry to make it actually real. So that's why, so the picture you saw before, until it hits really the industry, it takes really time. You need to be at the right cost level, the right simplicity of use, because when you program a vision system, it's quite, not easy, but it needs to be robust. Robust is probably the most important one, which is it needs to work 99.999%. Our robot, or my robot that we developed, well, we showed it to the DFG, which is the German Federation for funding, and it worked. But it doesn't mean that it really worked every day. So, and we all know that in research how it goes. And then you develop the next thing, but until you really get it done in industry, that takes some time. So what do we sell today? And I thought it would be interesting for you to see from the platform of AMRs, palletizers, paint robots, vision systems, and then all types. We have the full breadth of robots today. OmniCore is the platform that I talked about, and then we have the design elements. Just to show you the type of robots, we have smaller ones that go into smaller applications like electronics, and then larger ones that carry higher weights, size of the human, and then the larger ones, these are palletizers, and the ones that go into the automotive industry could carry up to 1,000 or one ton. And then the huge new generation of collaborative robots, and these were quite important for our customers because when we first automated the parts that don't need humans in the factory, that was a part that really went quite well. But then we went into the so-called final trim and assembly in automotive, where you have a lot of dexterity, a lot of complexity, unstructured environment. Obviously, we would love to have robots that work in unstructured environment. That means AI would be important, vision would be important, but we're still far away from getting there. So a solution is a robot that you can basically put and you collaborate with. The robot doesn't harm you if it hits you, but you can also work hand in hand with it. The other reason is that most robots are actually in cages today. And when you put a robot in cage, you have to have a parameter around it that basically takes too much space. But when we go to a factory, we see a line and we want to automate, you cannot say, okay, hold on, we will need to expand everything to put some real cages around it. It's easier to put a collaborative robot, and the robot will interact with the human, so the human can pass by and so on. So that's why the huge interest in collaborative robots was emerged. And then the pickers are a very specialized robot that basically has a high speed, can carry 1 kilo, maximum 5-6 kilo, but the speed is about 120 picks per minute, which is 2 picks per second. So a very specialized robot that was needed, and now is really a high runner in all the in the food industry, because obviously you want to pick all these cookies and whatever that is. You cannot have a small, a low speed robot. And then the other specific application is SCARA robots. And these are, they are not 6 axes. This is really a highly specialized robot, highly, popular in the electronics business. And it doesn't have much freedom of movement. So it's basically, I wouldn't even call it 3D because it's really planar, but it's called the SCARA robot. And this has a speed of 200 picks per minute, so 3 per second. So you can really tune it up. Obviously, you have to have the underlying electronics that would tolerate that. But these are all specialized robots that we developed over the time for industrial uses. So it's not only the 6-arm that we are all used to in universities. There are multiple others that are there. Now, the other category is paint robots. Now, paint robots, you would say, why is this special? In paint, first of all, it needs to be a quasi-clean room where you do painting. And when you see how it works, there's huge amount of obviously pollution and so on, but the robots usually to minimize the space, they are mounted on the ceiling or on the side. So they need to be structurally a different robot and need to have much bigger tolerance to the dust and the surroundings, and they need to be highly specialized. So also this is a very special type of applications that we built for automotive that was needed. So it's not always the same robot that is tuned, but really special application. Now, what is interesting to see is that tooling in all the examples that you saw are key. So we develop our own tools, but we also buy tools like grippers for food. Until today, we did not solve the dexterity problem, which is grab an egg or a cookie, don't destroy it. It sounds easy, and many, we can talk about that later, think that humanoid robots will be around us soon. Let's see. We're not able to do that in industry so far. So we build tools. We build tools to grab things. We build tools to cut, to weld, and and they need to be really customized to the object that you have. Obviously, we would love to have like a hand of a human that it has a lot of knowledge embedded in it without being needed to be programmed every time, reprogrammed. So that's also a phenomena in the robotics world. And then last but not least, as category would be mobile robots. They're around for quite some time. The problem with them was that they needed always a fixture. So you needed to have a magnetic line or some spots that you see, but if you don't see them occluded, it doesn't work. Which means that for automotive has them, they carry parts from one to the other. But every time you want to change the setting, you have to really move everything. You have to give the things apart, and they are not really programmable because, using vision, which would be the ideal, is still quite unrobust. And now we bought a company, 7 Sense. It's an ETH spinoff, and we worked ourselves on the navigation, which is a VSLAM at the end of the day. And now it's working, and it's phenomenal. I mean, customers love it. This is a video from our customer, Michelin, where they implemented it, and they really, it's basically localization by motion. While driving, it basically detects the edges and puts it in a map. And while driving creates the map, but it also prioritizes the items that sees. For example, if you see certain boxes, it doesn't put them in the map in the high priority. It keeps them, as variables. So, and then it constantly, makes it more accurate. And this is purely on vision plus odometry. And the accuracy is plus or minus 5 millimeter, which is quite high. Even slippages, it manages to work around it. I mean, whoever worked on these, I still remember slippage is a huge problem because odometry doesn't help you everywhere. Now, what is really cool is that you put one robot and it starts learning the other robot in a different part, so they all communicate and create a common map, and then they're able to navigate, and it really eases up the commissioning and so on. So, Ford loves it, Michelin, and many other customers now. And I think, it's for me also lessons learned how long it took from initial concept, because what we worked on at that time was basically stereo navigation using landmarks and trying to figure out the model, how to map and how to map the uncertainty using data fusion. We did that also with Greg Hager and other colleagues, and now it really is working. Now, what is it that how we think about how we create value for our customers? First, we need a platform, which is the robots, the actuation, the mobile. The other thing is we have domain expertise. So when we go to a logistics or any e-commerce company, we need to understand what it means to work in that setting. And then we have software. Now, over the years, software has become the biggest value driver for our robots. So obviously, mechatronics is still important, but the value driver for us is coming from the software. And that's how we make it that we started in automotive. but then we can model, we can create digital twins, and then we go into other industries. So we started in automotive, electronics, in general industry, food and beverage, consumer packaged goods and logistics. These are all the new, areas of growth. Still, automotive is quite interesting for us, but the shift changed over time from these industries to the others. Now, this is how the technology stack in our robot world works. We have the product, we have the functional modules, and then we have the actual applications. In parallel, we have Robot Studio design, the simulation, the motion control, the path planning, and then all the specialized applications that go on top. And then we have all our robots are connected remotely, so they're born digital. Whenever we install them, they get an address, and we can connect them, and we get all the information, and we do remote monitoring. We can tell the customer when will the robot fail. We do pattern recognition on them, and these are all services that we provide. Now, maybe let's go into this. So Robot Studio is basically the software that I talked about. We do the modeling of not only the robot itself, but the whole cell or even the line. And we go through, as I mentioned, with the customer and tell, this is how it would look like. We can tune up the speed. So sometimes the cycle time of 10 per minute is not enough. They want 20 minutes. But then we have to adjust other things. And you see the fences, the safety, all of that is part of the offering that we do. So we cannot just put a robot there with a payload of 30 kilograms, high speed, and without a safety concept for it. So that's how we actually deliver the value to our customers. And then we newest development of Robot Studio, we have it as on the app. So we can go to a customer. You can just put it in front. You can add a robot. You can pick the robot that you like, and it's all done virtually. And you can basically design the setting for the customer. And even you could add a tray and what have you. So this simplifies for the customer the access to robotics. And you can't imagine how important this is for customers, because this is high tech. So when you come and say, I want to put a robot in place, it always creates first anxiety. Don't touch a running system. But then we can show that it actually works, it's easy, and so on. And that's how we drive the value. And this is a cool example from how we use Robot Studio and virtual design. We did an experiment with the jungle keepers in Peru, where we basically helped them with a robot to actually plant trees in the Amazons. And it was all remotely done with this AR tool. And just have a quick look. So the robot would automatically plant, I don't know, 500, 600 per half a day. And it was an experiment that we did, and it was quite valuable because people did not want to move in that area. So we put the robot there, and he was really doing the plantation of these small, trees. And, you can think if you multiply that, how robots can add value in an area where we didn't think that is possible before. Now, how did this all evolution happen? So always you have new technologies that come from universities, come from our labs, and we have customer needs, and that's where we see the growth coming from. Now, over the years, there was interesting patterns. So from the 1970s to the 1990s, there were the initial automotive growth. And then new variants came in. And interestingly, between 2010 and 2020, there was this hyper growth. And that mainly actually came from China and from electronics. So electronics, why? These are the number of robots installed worldwide. So we're now above 500,000 robots. Now, electronics needs smaller robots, and the value is not as high, but they're smaller. And in China, I'll show you later how the density of robots rose to a level that now we have half of the worldwide installed robots are in China. So every year, 500,000, 2022, 250,000 robots were installed in China, 250,000 installed the rest of the world. So it's the production hub of this planet, which is quite important to know how these dynamics of this industry actually work. And then here we started seeing AI and vision driving more applications. Now, what is driving the need for robots? First, it's the individualization of consumer. So when you hit the button that I want to buy something from Amazon, you can't imagine what is the actual chain behind it that makes it happen that you actually get the delivery next day. It's a huge request on the logistics, on the retailer, and the manufacturing, and that needs robotization. Digitalization is a big trend. Labor shortage is probably the most important one that is here and here to stay. And you know, in the United States, we will have in 2030 about 1 million, more than 1 million open jobs just in manufacturing. There are missing about 300,000 welders in the US. So if you want to, you know, reindustrialize the United States, it's not going to happen because, you know, without the help of robotization and automation. And then last but not least, uncertainty. We all, after COVID, after all the geopolitical, challenges, all countries are trying to reshore, to bring back home manufacturing. And that means that you have to add automation. If you want in the United States or in Europe to actually reindustrialize, you cannot do that because there are no workers. So there will be a huge demand for robotization. So it used to be that productivity and quality were the key drivers in robotics. So I wanted to reach more, and the quality to be high. The new drivers are now flexibility and simplicity. Make the robot simple, make it simple to get access, because smaller sized companies don't have PhD workers there who can program the robot, so they need it easy to use. We have robots that go into bakeries now, but you wouldn't find engineers sitting there and programming. So you have to find easy ways, like teaching by observation, teaching by grabbing the robot arm and placing it into two places, teaching by block programming. These are all areas that we are working on to make robot access simpler, and that drives the demand for robotization. Now, the areas that we work on in terms of research are, one is autonomy, the other image processing, the other is mobility, and more analytics and AI. These are the four areas that we research internally, but we also collaborate with outside. But these are the areas where we also acquire companies or startups. For example, here we bought a company that does texturous, imaging for surfaces, mobility. We bought a robot company that has mobile robots plus the software, and autonomy. We work with universities and others on that. Now, interesting is to see how is this robot density around the world. So there is a figure that called robot density, which is number of robots per 10,000 workers. So when people talk about robots killing jobs, the average worldwide is about 100, 180. So 180 robots per 10,000 workers. We're not close to robots really taking away our jobs. They're taking away specific jobs. So South Korea is the highest, Singapore, Japan, and Germany. China really rose from 108 to 400 almost from 2017, 22. So they are now at par with the most of the others. US is also catching up, is now the second largest market. But look at the other countries where most of the reshoring is coming from, like India, 7 robots per 10,000 workers. And there's huge potential for growth in India. So you can imagine what that would mean in terms of size of usage. But then you have to find a way to make robots easier to program, easier to access, or else it will not work. You cannot have sophisticated automotive, applications. When we go to automotive, they love our, software suite because you can tune it into every single detail and so on. If that's not missing, I don't like that. I want to add this and so on. These are quite complex software tools that we give them. But when we go into countries where we need to get the boost, it will not work. We need to have simpler applications. Now, what is interesting is that 2017, automotive 123, electronics 122, and the rest was 155. And this picture was even different before. And you see that all other applications started actually to increase over time. And then by 2023, we have now electronics higher than automotive and all others the highest. So there's a shift also from demand. Automotive continued to grow, but the other industries like logistics, food and beverage, healthcare, all are on the rise. And if you look at it from what kind of applications is there, you know, material handling and machine tending, 43%. But actually, that really did not change. So the machine handling, which is feeding a machine and handling, was the highest portion. Welding makes about 16, 15%. Assembly, dispensing, processing. So this is how the applications of robotics actually look like today, which is also drives also what do we need in terms of research and so on. We divide, you know, two types of application. One is what we call process, that you follow a path like welding or painting, or pick and place. Pick and place doesn't need as much accuracy. It's a less complex task, but it becomes more complex when you have an unstructured environment, because you start want to pick packages for example, for, you know, e-commerce and so on, there where AI will play a bigger role. How we look at industries is the following. We have industries that are more on the upper S curve, which is automotive and electronics. They continue to drive innovations. For example, now a huge demand for battery tray assembly, new electric vehicles. So this is still a vibrant, you know, industry for us. And then we have the ones in the growth area, like food and beverage, logistics, appliances. And then we have, you know, rising industries. Now, construction and healthcare are not new industries, but because of the complexity and the unstructuredness of the environment, they have not been, you know, addressing the automation as much with robots as we would have liked it to be. Now, interesting example is construction. So here we invest, and here we look outside and we look for partnership and to drive it. Take construction. Construction is one of the largest industries with growth, you know, 15 to 15 trillion, and huge amount of, you know, global energy related to the construction industry. So now we worked with many, you know, companies. How do you can manufacture beforehand? So how are you going to construct a house a priori and in a factory, and then ship basically the structures to the factory, to the site, and then build the house. So this is an example where we worked with a customer, Autoval, here in Idaho, and let me see, probably this, where I'll let the video run. Houses with wooden structure that are pre-built.
Robotics has been a very critical part of all of the stuff. Say longer. Workforce that doesn't need to be doing all the heavy lifting and straining that people do. It's a huge problem to solve. Affordable living, affordable housing, the shortage in labor to provide that, it's not going to get solved unless robotics is part of that solution.
So this is an area that is growing rapidly with us, where we work with our customers. And you know, in construction, about 25% of what you put on the site is actually waste. So the more you can customize before, you reduce the waste and you make it actually more robust. It's an emerging area. But again, because that industry is also more unstructured than others, the access to it is more difficult. Automotive is highly repetitive and high quality, high repetition. That's why it was conquered early with the other area that is interesting for us is logistics and how manufacturing will change over time. Why mobile robotics in the combination with robots are becoming very, very crucial. is that we can't have fixed line automation as the standard in the future. We will have cells of automation, and instead of a fixed mounted, transport, you'll have the AGVs transporting material for you. So you have to have the coordination between the mobile robots and the robots themselves. And if you need more capacity, you can increase a cell or two. If you want to reduce it, you take it out. And that's how the manufacturing space will become more flexible. But that means also different thinking. You can't have these fixed lines where robots continue to do the same. You have cells fed by AMRs. And these are concepts that we work now with automotive customers to realize. So, and that means that when you hit on the button here that you want to actually order something, you have to automate retail, consumer-facing, fulfillment, distribution centers, and the factory automation. So all will have a need for automation, and all will be sectors that we would work on. And now I won't go into this video. Now, maybe just some examples of what the areas where we are working on for the future. One is mechatronics, how to actually push the boundaries of physical performance without touching the mechatronics, using pure software. The other one is make robots more mobile. And the other one is using software, expand the ability to work in an unstructured environment, and then using Gen AI and natural language programming to make the robots basically easier to interact with. And an example is we had usually force sensors are usually mounted only on the motor, basically on the wrist side. We added sensors on the load for a simple reason, because our collaborative robots, for safety reasons, needed to have a force control at the end, so we knew when you touch something. And interestingly, that was a way for us to increase, one second. The accuracy of the robot increased significantly using end, sensors at the end effector. This is a movement that was not possible before. It has a tolerance of 0.1 millimeter just by adding basically a sensor. So we didn't touch the hardware as well. And I was really also for us, for the Mechatronic colleagues, wow, just by using software and additional sensor, how much accuracy you can actually increase. The other area is making robots more mobile. There are researches that we're working on that, especially for laboratories, we would need more robots that do omnidirectional movement, and we mount robots on them. The other area is obviously an area that you're quite familiar with, we have robots with known items in unstructured environment, known items in unstructured, and then unknown in unstructured environment, which would be the holy grail of robotics. These are areas where we're working on. And then last but not least, how we can use Gen AI and natural language to... this is in China, where we're experimenting with this.
All the blocks on the part to be able to place the red block in the middle of table 2.
So, I mean, for the ones who are in robotics would know that this is not an easy task to do, to say all the box. What is all the box? How to interpret what means the red box, put the red box on the other table. Obviously, using natural language here will be much simplified with Gen AI. This is not available for sale yet. This is an area we're working on. And obviously, at the moment, Gen AI is a little bit, I would say, a little bit hyped that you can solve every problem with Gen AI. So I think there will be specific areas. We all have been in AI, know that, you have to basically, confine the problem in a certain space, and generalized AI, in my opinion, will take some time. So, but it's an interesting area of work. So I promised to give you a quick overview of what is happening on the side of AI from a company like us. So Obviously, you know the hypes of AI. I personally think that, you know, the maturity of AI has been growing, and we have the AI winters and summers, and we have been researching now for more than 10 years on AI. Obviously, the question is, where will this go? Even if we would have an uptick in expectations or down, the maturity of AI will continue to move. Yeah. So I tell, you know, colleagues or whoever want, you know, don't get discouraged now if this thing will at some point go down. It will. I mean, we are in a stage where everything extrapolation is just like getting into, you know, being too much. But obviously, we know that the maturity of AI will continue to go. So for us, we decided as a company, how do we want to structure AI for us? And we said either it's analytical AI, so pattern recognition, or it's Gen AI. Either the projects are external, so we use them in our products for our customers, or we use them for internal efficiency improvement, like AI assistant code generation. These are quite powerful tools that we can use to improve productivity. And then we said the project could be either implemented, under development, or planned. Implemented means it's real, and under development means it's going to be real in 2 years. And then planned, these are the ideas that usually generate the hype. This could be possible. This could be possible. So what did we do? We said we have about scanned the whole the company. We have more than 100,000 employees, and we were sent more than 100 projects. Real projects are out there, and many of them implemented, like the VSLAM, Move and Pick, and in other areas of ABB. But we have also a lot under development, like customer contact chatbot, where we allow our customers to use chatbot to contact us. And then we have a huge pipeline like HR. You know, when you want to have some rules, you don't have to search books. You just use a chatbot for that. I mean, these are areas that I think will have a value. But then over time, actually, we saw a huge uptick in number of projects in the company. Some moved to more the implemented, the pipeline was filled, and some fell off. And that's how we track basically the real benefit of AI. Because we want to avoid that we get into this, okay, everything needs to ding, and everybody gets anxious. Are we doing enough, and so on? So this is across the whole company, how we are monitored, and I'm driving that for ABB. And I think it's the right way to do it. These are just some examples how across ABB we use AI. This is a cool one. I mean, this is an offer we have today. Building like this, it monitors the movement of people in and out, temperature outside, temperature inside, and it regulates automatically based on pattern recognition, the temperature, the inflow, and reduces CO2 emission. Very, very simple. It's an offer that we have today. It's pure AI. The other one is obviously item picker. That's nothing new for you, but using vision to do item picking, you know, is now solved, but it took some time. And then we have a very cool, application from our marine business where we do the navigation for ships, and it basically does the full automated detection of ships in front of for the captain. And it basically simplifies the world. This is similar what we have for, autonomous driving, which still needs to pick up, and we're not there yet. So it's semi-automated. And then internal use, we use AI for coding assistant, and it's up to 50% faster. Customer contact. Very simple example here. You might not be aware, but when we get a project to build a large, a plant, just to design a motor, we get 200-300 pages of specs just to have to read through and so on. So colleagues came up and said, I would put this in a tool like ChatGPT, and it basically puts out what is the requirement for that motor. It's instant, it's fast, and it's quite powerful. That's where I think also the power of Gen AI will be, and then many other applications as well. So, and this one I can skip. So maybe I would end. So at the end, what we try to do is we try to either do it ourselves. We try to partner with universities. We don't have UPenn yet on it, but there's ways we can expand that. we invest in startups. We have an investment arm that looks at startups, and we try to, monitor and see who is, who's out there. For example, this company, 7sense, where is it here? Intrion, Asti, 7sense was this ATH. We have every year a challenge that we ask certain questions to startups. If you want to solve these problems, this was the company that actually had the best result. And at the end, we invested and we went into it. And then we have internal innovation. So we try to play it in an ecosystem that we don't say we do it ourselves. The speed of innovation is so fast in our industry that if we do it ourselves, we will not be ultimately successful. So also that's one of the reasons I'm here, to also to listen to many of you and to better understand where we are and to promote this continued learning and innovation. So with that, I'm very happy for your listening, and I open up for questions.
Yeah.
Our panelists,
Thank you.
Okay. Yes. Thank you very much for the great talk, and let's enter the Q&A section. Okay. For online audiences, please share your question in the chat.
Thank you, Sami, for the great talk. So I have a question. You talk about many industries like construction, medical, manufacturing. How about agriculture? Any thoughts on the state of automation in agriculture, and what are some of the challenges and opportunities?
Thank you. It's a very good question. The agriculture actually went through a high industrialization, but used fixed automation. So I mean, it's quite industrialized. If you read history, it's 100 years ago, but a big portion of human beings were actually working in agriculture, and that portion went down. That was all automation. But robotics was not really part of that. Now we see an uptick. We see an uptick because robots are becoming easier to use. We have many startups who have really cool ideas, like tomato cutting of the edges. So the robot would go into the row and then basically start trimming or cutting basically. And why is it more difficult? Because this is a highly unstructured environment. And again, when it becomes highly unstructured, robots are not as good as we would like them to be. And now with vision, we're becoming much better. So they take a picture of the tomato, recognize the edges, and then they basically do the cutting. So we will see more and more applications. The more we see these robots becoming equipped with vision and with the ability to navigate in an unstructured environment. What you don't want is that the robots function 80–90% of the time, but when they fail, you have to bring someone in. Then automation becomes a no-go. Like automotive, when we go to automotive, they want 99.9% because they say, if every time this thing stops and I need to bring in 2–3 people to it, then I don't need the thing. And the same here. Thank you. Yes.
You mentioned all these projects that went from AI projects that went from prototype to implementation. Can you give us any insight as to which project made it through, why, and which ones didn't make it, and whether the challenges were technical, economic? Yeah.
The couple of them who went from left to right were the ones where we already had a good solution using analytical AI, like, for example, remote monitoring. And the teams added Gen AI capabilities, for example, speech to the machine. And I think that's an area where we will see more traction. These were areas that actually developed quite well. One of them was the monitoring side. So all the ones that you saw on the right had an element of Gen AI on the left, where you had start interacting. That was one pattern. The other one is many of the applications, if you remember the digital hype in 2000, where everything's going to be digitized, but it really didn't come as fast, is when things are not integrated into the workflow of the normal working people. Because at the end, if it doesn't, help you in your daily life and it's becoming only theoretical, it is not going to help you at all. So, take ChatGPT. Yes, you can use it outside, but when you use it internally in a company, we have stricter rules, because obviously when you put IP into ChatGPT, it's gone. It's basically then public knowledge. So you have to make it work in your environment. That's why we have now ways that we use, ChatGPT tools internally. This would be another example. Microsoft offers that, for example. Yes.
Thank you for a really wonderful talk, Sami. I wanted to get a sense for when a new customer comes to you with a particular use case, between the time that that customer comes to you and between the time that a product is available. I'm sure the answer to this depends a lot on the specific type of customer, how much experience you have, et cetera. But what are the steps involved? Like, what are you doing internally to figure out what needs to be done? Do we already have the skills? Do we need to develop a new skill on a robot, et cetera, et cetera?
But these are the steps. So first, we want to know if this is an industry that we are familiar with. The other is an application that we are familiar with. And then what we use is our simulation tool to see if the problem is solvable. And then what we typically do is we send a team of experts. I get these requests quite often from automotive and others. Send a team expert. They go and look at the line. And these colleagues have a good feel of what is possible and is not. And then they say, okay, let me have a look at the design phase. We do simulate, and then we present it to the customer and say, could be solved this way, or the other. Then we decide what kind of robots we'd need. Do we need more collaborative or more standardized robots, and so on. So this would be the approach to get there. It's not always a straight line, but I think, and sometimes we see areas where there's room for innovation, and then we take it aside. Like logistics a couple of years ago was an area we're getting a lot of requests because the customers were having a challenge with hiring. The Amazons of the world. I mean, their biggest challenge is hiring people, and many of the e-commerce companies came and asked, "Could you solve this problem?" And then we set a team aside, like an incubator in UK, actually, about 10 people, and said, "Okay, develop a specific solution for e-commerce." And now it's a $100 million business where they created it. Another example, I went with a colleague to a catering of airlines, and then we worked around and we were requested just, why do we have actually so many manual work? And because it's also a hygiene factor, especially after Corona. And it was interesting, there was actually no reason, but in general, people are used to it. People say, no, this can only be done by humans, because putting, the cheese and what have you on the plates and so on. But we said, okay, let us do a pilot for you and show you that with hygiene robots, you can do that in a much, much more effective way. There, the challenge is more, how do you get through the resistance in the organization for new things, as opposed to it's doable. We show that it's doable, but that is part of management, how you deal with that, how you deal with the change management that goes behind it. That is not to be underestimated, how when we deploy robots in an area where it's new. When it's standard, then everybody knows, okay, there's no discussion. I need to get productive, like in automotive. Jen?
I apologize again, I came late, but I spent most of my life in education. So question number one, I have many questions. We'll continue this conversation. But when a young person comes to you, what are you looking for? Analytical skills, design skills, collaborative skills, attention to details? What is it? What are you looking for?
That's a very tough question. Well, I mean, I don't want to answer. It depends, but it is obviously, if we have it in in R&D, obviously there's different skills than in sales. Sales, we would need more communication skills, collaborative skills and so on. But I can tell you that in general, for me, when I recruited over the last years, at the beginning, I was much more interested in deep knowledge. I became much more interested over time into more, this what we call EQ as opposed to IQ, the ability to collaborate, the ability to work with others and so on. Because in companies, we have to rely on the team at the end is a better thing than individual people. And that's how I think over time it's becoming much more important. How to detect that skill is very difficult. It's not, that's a question of its own. How in an interview setting, how do you know that that person is not too much of an individualized, obviously, thing. So it's a mixture of things. In marketing, we would look more for creativity. R&D, we would still need, deep, knowledge and understanding. And in management, usually we try to bring people from the organization to be, leaders, but that's also a different skill, managing people, feeling comfortable with, giving direction and leadership. Yeah. And not everyone is able to do everything. And that's also okay. Yeah. I hope I answered the question.
Yeah, thank you.
A little bit.
I can tell you, my husband, at one time, I was a chair of a department, and I asked him, what should I look for in a new candidate? And he said, look for a certain restlessness, nervousness. And because if somebody is too easy,
Comfortable, yes.
fine, forget it.
That's a message to you all here. Thank you. Thank you.
Sami, very insightful talk. I see throughout your talk a theme of customization, right?
Yes,
And, I heard it also from other successful companies like Berkshire Grey. But how can this scale up? I mean, if this has some kind of a limit, right? I mean, we want to get it into houses or into restaurants or into hotels. How can we?
I think it's a very critical question for a company to be able to make profit at the end, which is, we need to deliver to our shareholders. So what we do is we have like a pyramid. The lower part of the pyramid, actually, we try to standardize as much as we can. So for example, the individual robots, that needs to be really like cookie production. We can't have any deviation. So, whatever, 800 kilogram robot, that needs to be developed as is. And then we have a second layer that we try to, say we'd call functional package, and then we have the cell. The functional package, is some grippers added to it. That's how we add more flavor to the robot. But the individual grippers will be also try to standardize them. And then we have the software layer. The software layer allows us to play a lot more with it. So whatever goes out of the factory is highly standardized. Even the cells, the larger one that you see, we try to standardize the safety concept and everything that the colleagues on the ground, when they get a request, that they just put like an IKEA or a Lego, we put the elements together, or else it will not work. The more customized you are, the less your profitability will be over time. That's why, in many industries, like in construction industry, where everything is new, profitability levels are usually much lower than if you have high, standardized production. So we try to balance these two. At the same time, accepting the fact that every customer is somehow different, but also customers want to have affordable solutions. So that's the dilemma between the two. But it's a constant discussion we're having internally, how to manage customization versus standardization.
So there are two questions online. I guess they're more about the specifics of the skills you showed. Jack asked, with many of these robots, it appears that they have a task that uses a single tool on the end effector. Do you commonly support robots that adapt to different tasks using tool changers? Are they able to take advantage of some of the newer AI and ML technology you're implementing? And another question is, I would ask.
Maybe I'll answer with the first one. They're not easy ones. So yeah, we actually we have robots who actually can change tooling themselves. So we would have an arsenal of tools that the robot will go and then change. That is possible already today, but it doesn't have AI in it. Where the development is going is that these tools themselves become much more flexible. For example, grasping food. There's a partner we work with where it is basically based on air, and basically just surrounds the apple or the orange. So it really doesn't matter the size of and the weight of it. The tool adjusts itself. That is how we solve some of these problems. But I cannot figure if there's anything where we use AI for the tooling part. I mean, the tooling, there is a huge industry that supplies us with tools, from welding guns to whatever. So obviously, we would love to have less variety there, because then for the customer, it means I can do more with one single tool, or I have to stack all that stuff for me. So that is an area of development for us in the future.
And another question is, I guess you show like humans specifying the task to the robot and communicating. And then someone asked, I would like to ask if you see large language models playing any part in the development of robotics in the future?
Yes, that what we saw here was based on large language model application. There were two areas. One is using complex programs where you have to program yourself. We use a language called Rapid. But then the level above would be block programming, where you have blocks with defined skills. So we try to abstract more and more that the end user doesn't have to actually learn all the detailed languages. And the other way would be from natural languages to the program. So can you give an instruction of a box, a green box, put it on the table, and then from there go down to individual tasks. So these were the two areas that we're looking at. But I would say we're still at the beginning of that area. Yeah. But I believe a large language model, and not only large language, but language models in general, will help us there. Question there. But yeah, you can.
I'm going to pass this.
Thank you, Sami, for the very eye-opening presentation. You were talking a lot about the labor shortage, and I was interested on what are your thoughts about the new challenges that the industry of robotics and mechatronics needs to solve to be relevant for greater applications? For new and greater applications.
Especially in the context of labor shortage? Yes. Yeah, I mean, a good example is welding. Welding is a job that not many want to do anymore. I mean, as I said, hundreds of thousands open positions in welding. And so we worked with a company called Lincoln here in the US, where we provided a solution. It's basically a collaborative robot that we mount a welding gun on it. And the welder has to take the gun and basically move it across. It would be basically an expert who would do it. And then the system would learn over time. That's a good example of how we can support, and we even teach young welders actually how to use the system. So that increases your productivity as an individual, and you can actually do more than what you could do before. That's a good solution for that. And there will be many of these examples where robots have to become much more easier to program. So this teach-in would be one. The other one is observing a robot while movement. We have an example where a robot sees someone writing Chinese calligraphy when you go to our factory in China, and then the robot basically observes and just starts writing basically the same, just through pure observation, and many other examples. Obviously, we all know that dexterity is not solved that way. So you see some robot grasping something. It doesn't mean that now you understand how the grasping process would work, although many claim that by just pure observation, we will solve all these problems. I think there is much more inherent knowledge in us and how we grasp and how we operate then it's possible just through pure observation to do that. Yeah. But that will be the development, or we will not be able to close the gap of labor shortage. Yes.
So I have a question about startups, investment and acquisitions. So what is the approximate due diligence and decision-making process to invest in or acquire a startup or a robotic startup?
So what we usually do is we have a process every year that we pose a question of 3. This year we had it more towards Gen AI and skills. So the startups will come and show us what they do. We have options: either we invest or we collaborate. If we invest, usually a minority, we can do a very fast process. So that's not a cumbersome because we're not acquiring a majority. It could take a month or 2 that we make a decision. But if we want to invest as a full company, it might take us 2 months or 3. Because when you acquire a company and it's basically then your own, then you're also responsible for everything that is in that company. And that makes it a little bit more difficult because then you have to look at HR policy, you have to look at all the contracts that company has ever signed, because then you as a large company are liable. That's why the full acquisition is a more cumbersome project, but it shouldn't take more than 2 months or 3.
Let us thank Sami for the wonderful
Thank you.
talk. Thank you for the lively discussion.
Thank you.
And please join us again, I think, at the beginning of the semester for the Grasp on Robotics seminar.
Thank you very much.